Let's move to the last part in this lesson, inverse trigonometric functions. Every time, guys, I'm talking about inverse functions. What does it mean, inverse function? First, the notation of f minus 1 of x. So if f of x is a function, its inverse, the notation is f minus 1 of x, exists, and we saw that in chapter 2, if f of x is one-to-one function. And we saw that in chapter 2. What does it mean, one-to-one function? To know that a function, it's a one-to-one function, I have three methods, or I have three ways to see that. First, if the graph is given, I need to do the horizontal line test. And the horizontal line test should cut the function in exactly 1 point. So if I have a function and I do the horizontal line test, if it cut it more than 1 point, it means it's not one-to-one function. If I want to talk about it algebraically, if I have the values, every element in the range is the image of exactly one element in the domain. What does it mean? If I want to explain different way, it means not two values of x have the same y. I cannot have the same y for two different values of x. Or also we can talk about it differently. We can say it's a monotonous function. What does mean monotonous? So the function is increasing or strictly decreasing. So, or I can see a function that is going up, or I can see a function that is going down. So I can say that this function is one-to-one function, and we know how to find it algebraically and graphically. But here in this part, we are doing the trigonometric inverse functions, and it means sine and cosine functions. So to graph the inverse of a function, we do the reflection of the function with respect to y equal to x. So when we are sure that this function is one-to-one function, I can graph it by doing the reflection with respect to the first axis of symmetry, the y equal to x. So now when I'm talking about sine x, what does it mean inverse? Sine x is equal to half. So to find x, we need to use the inverse operation of sine x. So, and what is its inverse operation? It's sine minus 1 of x. Or we can also consider the notation arc sine x. If you take the calculator, guys, since I have the answer of sine, and you need to find what is the angle that gives me sine x equal to half, you put on the calculator, if you notice that, shift sign. And when you put shift sign on the calculator, you will see that the calculator will give you, or will write sine minus 1 of x. So this one means the inverse function of sine of x. So when I have the answer and I need to go back to see what was the angle, this one I'm doing here, the inverse function of sine x. So to be able to understand what we are doing, I just need to do this exercise, and that's it. First step, the question, first exercise, the first question. Example, the first question is to sketch the graph of f of x equal to cosine x over 2. So it's a normal exercise like the preceding video, so I'm doing it again so you will get it more. First, what is the amplitude? It's 2. The period, it's 2 pi over half, so it means it's 4 pi. So it means I will start, I don't have any shift, I don't have any vertical shift or horizontal shift. I'm not going up and down or not going left and right. So it means that I'm starting at 0, and where I'm ending at 4 pi. So my period starts from 0 till 4 pi. How I know what are the other points of this interval? So I divide 4 pi by 4. 4 pi minus 0 over 4, it means it's pi. So every time I'm ending pi. So 0 plus pi, plus pi, 2 pi, plus pi, 3 pi, 4 pi. So those are my particular points. So I have it here, 0 pi, 2 pi, 3 pi, 4 pi. Since the amplitude is 2, so I'll start by 2 and minus 2. It's not 1 and minus 1. So it's 2 and minus 2. And then we know that cosine start from up here, not from 0. So I'll start from this point, I'll go down, and then I will go up. Okay, excellent. This is my first question. Let's move to the second question. Determine the domain for a one-to-one function occur. So is this function a one-to-one function over all its domain? No. How can I see that? First, if I do the horizontal line test, look guys, it cuts in 2 points, so it's not a one-to-one function. Second, also, if I want to see it, say, is it monotonous over all the domain? No, it's decreasing then increasing. So I need to restrict the domain. So either I can say over 0 to pi, either I can work over 2 pi, 4 pi. I will just work over 0 to pi. So I will take just the domain 0 to pi. So what is the answer here? X should be between 0 and 2 pi. So I took this interval, guys. So this is the answer. So it's between 0 and 2 pi. Now, the last question here, I want to sketch the inverse f minus 1 over x. So how are we going to sketch it? So here also I have a mistake. It's 2 minus 2. So I have this one. I need to graph its inverse. To be able to graph its inverse first, I need to draw the first xy equal to x. So I will do it. So here it's 2 minus 2. And then I need to do the symmetry with respect to y equal to x. So you know that the point that's here, it's still here. This part here, its symmetry gonna be down. To be more sure about that, what are you gonna do? I'll take this point, I'll do the perpendicular, same distance, so it's gonna be here somewhere. And the down part gonna be up. So we will see it here on this graph, but here I need to fix 2 minus 2. So here I have it more accurate. So if I will take, I'm just going to do this first part first. So this point is here. So if I will do it on my copybook, so if here there is 2 boxes, so it's simply going to be here 2 boxes. So this one going to be here. And this one is here. So it means this part, it will be this part. Now the other part, for example, this one is on the third box. It means this one pi going to be on the third box, 1, 2, 3. And then if you look at this one, it's 1, 2, 3, 4, 5, 6 minus 2. So it's going to be now minus 2, 6 because it's symmetry. So this is minus 2 here. 1, 2, 3, 4, 5, 6. So this point is going to be here. And then this one is 3, and then I join it. And if you look, guys, at the green part and the blue part, they are symmetry. If you flip it here on y equal to x, you see that they will overlap. So this one represents the inverse. This is f of minus x over the domain that we picked, and this is f of x. That's it. So this is all our lesson about. We will do sure more application from the book during our session in the class.